Good af Good evening, everyone, and welcome to the lecture. This is lecture number 2, and we are dealing with wave optics. Yes or no? In the previous class, we had seen the basic terms of wave. We had seen the wave equation. We had seen what is displacement. We had seen what is amplitude. We had seen what is phase difference, omega, time period, and so on. I hope we remember this. Yes or no? We had
Yes,
seen what do you mean by leading wave, lagging wave. We had also seen the relation between phase difference and path difference and so on. Yes or no?
yes,
What is phase difference? What is path difference? We had seen that. Okay. We had also solved a question based on phase difference and path difference. We had seen how we can convert phase difference into path difference and path difference into phase difference. Do we remember this? This particular question where the phase difference was given as pi by 3, we had calculated the path difference. Yes or no?
yes, sir. Yes, sir.
Okay. Today's class, what we will do is we will start with the next concept, and that concept is the concept of superposition. And that concept is the concept of superposition of waves. Now, what do you understand by superposition of waves? You might have heard something known as superposition of forces. Have you heard that term, superposition of forces? I think in the 11th standard, we had seen this point that if I have on a particle, if I have a number of forces acting on it, let us say F1, F2, F3, and so on. Do you remember that superposition of forces? If we have to find out the net force acting on this particle, how do I find it out? If I have to find the net force acting on a particle on which a large number of forces are acting, how do I find it out? Anyone? No one remembers it? How do I find out the net force acting on the particle? I find it out by adding all these forces vectorly. Yes or no? Do we now remember it?
Yes, sir.
This principle, which is right now in this red box, is known as, oops, the red box is not looking good. This principle, which is now in this red box, is known as the principle of superposition of forces. The net force acting on the particle is the sum of vector addition of all the forces together. Now, a similar thing you can understand in terms of waves. And the best way that you can understand wave may not be in the form of light wave, but it may be in the form of a sound wave. Now, sound waves are also waves. When sound waves are traveling in a medium, there are particles in the medium, and those particles are also oscillating or vibrating. Do we know this? Yes or no? Sound cannot travel in vacuum. That's what we have heard, and because there are no particles, so the sound cannot move. But right now, I just saw some new discoveries by NASA where they were able to hear sound of distant galaxies coming. It was such an astonishing feat to hear those sounds. Anyways, whenever any wave is traveling in a medium, the mediums of the particle oscillate or vibrate. Yes or no? Now,
Yes,
if one wave is traveling, because of that, the particle would be oscillating. But in your room right now, there is not only just one my voice, but you can hear other voices as well coming from here and there. And these voices are all waves which are traveling in the same medium. Now, when they are traveling in the same medium, they are causing the particles to displace according to their equation. But whatever this wave is doing, the other wave is independent of this wave. I am producing other wave. I am producing my own disturbance. This fan is producing its own sound wave. It is producing its own disturbance. Your friend who is sitting next to you and you are busy chit-chatting with her, she is producing her own sound waves which is also making the particles to vibrate. If I have two or more waves which are traveling in the same medium, the net displacement of the particle, is equal to the sum of displacement produced by all the waves. This principle is known as the principle of superposition of waves. So what do you understand by superposition of waves? What do you understand by superposition of waves? If in a medium one or more than one waves are traveling, the resultant displacement is the sum of displacement produced by all the waves put together. This principle is known as the principle of superposition. Do we understand this? Yes or no? No, yes.
Yes, sir.
So you can note this down because this is what you might require. Principle of superposition. This principle of superposition states that when two or more waves are traveling simultaneously in a medium or they are passing through a point in the medium, the disturbance of the point is given by the sum of the disturbance of the wave. So if the first wave I call as y1, which is a1 sine omega t, and the second wave I call as y2, which is a2 sine omega t, plus let us say phi. If I have to find out the net displacement or the total displacement, how will I find the net displacement or the total displacement? The principle of superposition says that the net displacement or total displacement y will be equal to y1 plus y2. Do we understand this? The net displacement by the principle of superposition will be y1 plus y2. I hope all of you are noting this down. Yes or no? No, yes.
Yes, sir.
Net displacement of any particle when two or more waves are traveling is the sum of displacement of the individual waves. This principle is known as the principle of superposition of waves, and it is similar to the principle of superposition of forces. I will give you 2 minutes to note it down.
Done, sir.
Done, sir? Okay. Now, if you look at the two waves that I have written here, wave number one, this one, and wave number two, this one, some things, some quantities are written as same, and some quantities are different between the two waves. Can you tell me which are the quantities that are same in the two waves and what are the quantities that are different in the two waves? And I asked you the same question yesterday also. I wrote the same equation yesterday also. And then I asked you Which quantities are same and which quantities are different? What do you think is same in both the waves and what do you think is different? Yes. Tell me something first. What do you think is same in the two waves? Wave Y1, which is wave number 1, and wave Y2, which is wave number 2. What thing is similar or same? Do you find anything similar or same?
Sin omega t, sir.
Not sine omega t. Sine is the waveform. So the waveform is the omega, omega, which was angular frequency. This omega, which is the angular frequency, that is same. Do we understand this?
Yes, sir.
That is same, but what about the things that are different? What about the quantities that are different in the two waves? Yes? What quantities are different in the two waves? If you look at this amplitude A1 and A2, the amplitudes are different. In first wave, the amplitude is A1. In second wave, the amplitude is A2. Then if you talk about this entire thing, omega t, this is known as the phase of the wave. The phase are different. Yes or no?
Yes, sir.
We have also talked about leading and lagging. Any one of these waves is leading and the other wave is lagging. Can you tell me which is leading? Which wave is leading and which wave is lagging?
Y2 is leading and Y1 is lagging.
Well done. So this is the wave that is leading and this is the wave which is behind, which is lagging. Everyone understand this? Yes or no? We had seen that in the last class. Okay. Now I have to add these waves. Something is kept same, omega is kept same, because if omega is different, it becomes very difficult to add them. That is why omega is kept same. How do I add this? So if I have to add this, I will write it like this. If I continue, so I'll write y is equal to a1 sine of omega t plus a2 sine of omega t plus phi. Now, to add this is not a question or is not the task of physics. To add them is the task of maths. We add them using maths. Now, how do we add them using maths? We see that we have a lagging wave. So what we do is we draw the lagging wave. We only draw the amplitude of the lagging wave. So we draw A1 as a horizontal line. And then since the other way is leading means ahead, we draw the other wave, only the amplitude like this. Remember, it is leading. Anti-clockwise angle is positive. Positive angle means it is leading. Therefore, I have drawn A1 as horizontal and A2 at an angle phi. Do we understand this? Now I have to add Y1 with Y2 and now I have drawn them. And it looks similar to something that we have already done before in your 11th standard. Does it look similar, these two things? To these things at an angle. Does it look similar to something? Does it look similar to this? Two vectors A and B inclined at an angle of theta?
Yes, sir.
And then we had seen that we can find out their resultant vector. The resultant vector is the addition of these two vectors, which goes like this. Yes or no? Resultant R.
Yes, sir.
What was the value of that R? No one knows it? I know that you know it. R is? Huh?
Sir,
Yes.
is it under root of a square plus b square plus 2a baby cos theta?
Are you asking me or are you telling me?
Telling, sir.
Yes, that is correct. It has to be equal to a square plus b square plus 2ab cos theta. Then you should also remember that this is inclined, let us say, at an angle psi. I'm not using phi because I'm using phi on the other equation. You should also know the value of this tan of this angle psi. Yes or no? It is equal to b sine theta upon a plus b cos theta. Do we remember this?
Yes, sir.
I've added this and I've given you this example. So similarly, I can add this. If I call the resultant amplitude as A, can you tell me what will the value of A come like without me telling you anything?
Under root a1 square plus a2 square plus 2a1 a2 cos theta.
A1 square plus A2 square plus 2 times A1 A2 cos not theta but phi, because this is phi. You can also tell me that it will be inclined at some angle xi. What is this tan of xi? Huh?
a2 sin psi by a1 plus a2 cos phi.
A2 sin phi by A1 plus A2 cos phi. Well done. I hope everyone is noting this down. Has everyone noted this down? I'll give you 2 minutes for you to note this entire stuff down. And I hope we are understanding what is happening. That is why I'm asking you to do it. 2 minutes you have.
Done, sir.
What about the other class? Are we done?
1 minute, sir.
Okay, bacha. Let me know once you are done, beta. Abhiram has done. Let's wait for all of the students to be on the same page as Abhiram and the girls. Girls, I think, have become more smarter than boys. That is good. Girls are anytime more
Completed, sir.
working. Great. Okay. Just give me a minute. Just give me a minute. Okay. So we are done. The problem here is I was supposed, see, where's my pen? Okay. Y1 was written like this. Y1 was written as A1 sine omega t. Y2 was written like this, A2 sine omega t plus phi. I had to find out the value of y actually. I had to write y in a similar way because y is the resultant displacement. But instead of finding out y, what I have done is I found out this a and I found out this xi. That was not my actual intention. My actual intention was to get the value of y. But I found out the value of a and xi. Can you tell me how can I write y? I had to write y, but I found out the value of a. I had to find out y, but I had find the value of xi. How do I get the value of y from a and xi? Or have I done something really stupid that I had to find out something, but I found out something else? Do you understand what I'm saying, bacha?
Yes, sir.
Can you tell me from a and xi, how do I write the value of y? From a and xi, how do I write the value of y? I'll give you 1 minute to think about it. From a and xi, how do I write the value of y? Anyone? Look at this A2. Look at this 5. And A2 was written like this. Y2 was written like this. Look at A2. Look at 5. And look at how Y2 was written. Can you write how Y will be written? Look at A2. Yes, bacha. No? Shall I help you? So Y will be written in this way, beta. Y will be equal to A. Which A? This A. Y will be written as A sine of omega t plus psi. This psi. Oops, wrong color. That is how I get the value of psi. That is how I get the value of Y. Do we understand what I have done here?
Yes, sir.
So I'll give you a minute to note it
Yes,
down.
sir. Done, sir.
Let us wait for all of the students to be on the same page. I like when everyone has done.
Done, sir.
Done, sir. Then we move ahead in life, sir. Life is all about moving ahead in life. So we move ahead. Okay, so we have written the value of y. Now, let us start from here again. A is the amplitude of the resultant wave. Now, there is one thing which is known as intensity of the wave. Intensity of the wave represented by I. Now, intensity of a wave is directly proportional to the amplitude square. And most of the question that you get in your exam is based on this concept of intensity of the wave. Intensity of a wave is directly proportional to your amplitude square. So sometimes, many times, they will ask you, what is the resultant, not amplitude, but resultant intensity? Now, how do I find the resultant intensity? If I call the intensity of the final wave, that is we are getting as I, what will be the formula of I in terms of I1 and I2? I wrote the formula of A amplitude in terms of A1 and A2. Can you tell me what will be the formula of I in terms of I1 and I2? Huh? You understand the question, right? I in terms of I1 and I2, and it does not take rocket science. If you understand it on your own once, I'm sure that you will not forget it. How can I write I in terms of I1 and I2? I've written A in terms of A1 and A2. And I've told you the relation between I and A. Can you help me out with writing I in terms of I1 and I2? Just dear friends. Bacha. Huh? Can you do it? No one? It's not rocket science. It is simple things. Simple things make life easy. Life is as easy as you feel it, as difficult as you make it. Yes, my dear friends. Come on, bring up your A game. No one? So the formula of I would be, I'm still giving you a chance. The formula of I would be, I1 plus I2 plus 2 times root over I1, I2 cos phi. How did I get this? How did I get this? I will square this equation. So we will have a square, and a square is equal to I, proportional to I. See, a1 square will be proportional to I1, a2 square will be proportional to I2, a1 and a2 will be proportional to root over I1 and root over I2, and hence we land up with this formula. Do we understand this? Yes or no? No or yes?
Yes, sir.
You could have done this, na? Was it so difficult? Okay, no worries. No worries. I'll give you 2 minutes to note this down.
Done, sir.
Everyone has done this?
Sir.
Okay. This was all about superposition. We have landed up with some formulae, and we will be using this formulae in the lecture that is coming up. But before going any further, let me introduce the next concept. The next concept is known as coherent sources. I have written it in a different way. I should not have written it like this. Coherent sources. Coherent source. What do you mean by coherent source? Anyone have heard about this term? Coherent sources. Coherent sources. Anyone heard about this term? No one? Coherent sources. Now, coherent sources are those sources of light or sound for that matter, which emit light of the same wavelength. That means they emit light of the same frequency, and they have a same or a constant phase difference between them. So whenever you talk about coherent sources, the two things that you must remember is they emit light of same frequency, or you can say same wavelength, because it is the same medium, same frequency or same wavelength. And the second point that you must always remember is phase difference, delta phi. Phase difference, delta phi, is always constant. If you have two sources of light that emit light of the same frequency, same wavelength, and they always maintain a constant phase difference between them, then they are known as coherent sources of light. And these coherent sources are very important because whatever we are going to discuss will be based on these coherent sources. Now, something given for your knowledge, because they might ask you a question based on knowledge, and so you can just note it down. This is just a knowledge based question. How can you obtain coherent sources, and where which type of coherent source is used? You will have to note it down. So I will just show it on a slide that you can note it down. Now, coherent sources can be formed in two different ways. The first way is known as division of wavefront. You remember wavefront? Wavefront was that thing that was emitted and it was moving ahead, and the wavelets and all that particles in the same phase. Do you remember that wavefront? All these are wavefronts. Do you see this wavefront? Yes or no? So the first method is by division of wavefront, and the second method is known as division of amplitude. Division of amplitude. Now in division of wavefront, what happens is, if I can just show it to you, see, there is one source of light and this is passed through a small hole, and then we have one more cardboard, let us say, and we make two small holes in that cardboard. So what happens is, here we have one source of light, but here from that same source of light you have produced two more sources of light. These two sources, S1 and S2, are coherent, produced by the same light. But as you can see, what has happened here is, the wavefront that was falling on S1 and S2, it gets divided. One wavefront is coming here, number one, the other wavefront is coming here. So basically what has happened is, the wavefront has been divided, and this type of coherent sources are known as coherent sources formed by division of wavefront. Do we understand this? Now, where do we use these coherent sources formed by division of wavefront? That is what they will ask you. In Fresnel biprism, in Lloyd's mirror, and in Young's double slit. In all the three cases, we have coherent sources which are produced from a single source by division of wavefronts. By division of wavefronts. Now, how do I get coherent sources? By division of amplitude. So what we do is, we make the light to partially reflect and partially refract. Some part of light reflects, some part of the light refracts. And then with those reflected and refracted rays, we produce sources which are coherent. That sources are known as sources produced by division of amplitude. These sources are used in Newton's rings, not in your course. Michelson's interferometer, not in your course. Thin films, interference in thin films, that is in your course, but question doesn't come. So interference in thin films, these are the three positions, three experiments in which you will have division of amplitude. What we have to understand is only Young's double slit experiment. And in Young's double slit experiment, how do we obtain coherent sources? We obtain coherent sources by
Wavefront.
division of wavefront. Do we understand this?
Yes, sir.
Now, if the sources are not coherent, that means they do not have the same frequency and they have a varying phase difference. They will be known as non-coherent sources. Do we understand this? Yes or no?
Yes,
Sources
sir.
of light where the frequency is not same or the phase difference is not same, are known as non-coherent sources. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay. These are all important points that are going to come. Okay. Now remember, one more point that I will have to discuss it here. Now remember, coherent sources of light. For sound, you can obtain coherent sources from different sound sources. But for light, you must remember coherent sources can only be produced by a single source. So remember, for light, coherent sources can only be produced by a single source. It cannot be produced by two sources which are different. For light, remember important point, for light, why I'm writing LIGTH? For light, coherent sources can only be produced by a single source. And there are only two methods of producing it from a single source. One is the division of wavefront, and the other one is the division of amplitude. Do we understand this? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to note this down. Important points about coherent sources.
Done, sir.
What about the others? Have you noted it down, bacha? Abhiram has done.
Completed, sir.
Wait. Okay. Let me know once you are done, bacha.
Completed, sir.
Okay. Then that brings us to the next heading, and that next heading is known as interference of light. I'm writing the wrong equation, wrong spelling. Interference of light. Now, sometimes student gets confused between the two terms, which is interference of light and the superposition of light or superposition of wave or interference of wave. Let me make it very clear to you. What do you understand by interference and what do you understand by superposition? So, and remember this, don't get confused because no one is going to ask you what is interference or what is superposition, but this is just for your knowledge so that you don't get confused. Now, as soon as we talk about interference, remember the important points. I will highlight them and I'll write them. When two waves are exactly same frequency. So the first thing that is valid about coherent sources is they must have same frequency. Do we understand this? Then
Yes.
they must come from coherent sources. So that means they must come from coherent sources. Whenever we talk about coherent sources, they must have a constant phase difference, constant delta phi. Do we understand this? Then they must travel in the same direction. So if these two waves must travel in the same direction. If these three things are met, if these three conditions are met, then because of their superposition, that means interference is nothing but superposition only, but it's a special type of superposition where you have two waves, two or more waves of exactly same frequency coming from coherent sources, traveling in the same direction with the same phase difference. At some points, what happens is intensity of light is minimum. Intensity of light is minimum, whereas some other points the intensity is maximum. This phenomena is known as interference of light, my dear friends. The phenomena of interference of light. So it is a type of superposition of two waves having the same frequency, coming from the same coherent sources, having a constant phase difference between them, traveling in the same direction. When they superpose, at some point you will have maximum intensity, at some point you will have minimum intensity. This phenomena is known as this phenomena is known as
Interference of light.
interference of light. I'll give you 2 minutes to note it down.
Done, sir.
What about the others? Let me know.
Completed, sir.
Okay, that phenomena is known as interference of light. Now, if I go back, if I take you back, and this is the time that I'm going to go back. Now, if I take you back to that thing that we had done, we had taken two waves. The omega of those waves were same. The amplitudes were slightly different, and the phase difference was constant. So basically what we had done is we had done the superposition of two waves which were coming from coherent sources traveling with the same frequency in the same direction. So whatever we had done here was actually interference. Do we understand this? So only these type of waves can undergo interference. So whenever we talk about interference, we again talk about the same thing. So now we talk about again the same thing. I will write it again. So we now have two waves, y1, which is equal to a1 sine omega t, and I have y2, which is a2 sine omega t plus phi. All the conditions are met here. These waves have the same frequency. They're traveling in the same direction and they have a constant phase difference between them. Now, when these two waves superpose, I get a new wave which is given by a sine of omega t plus psi. Yes or no, my dear friends?
Yes, sir.
Here the value of this A is nothing but A1 square plus A2 square plus 2 times A1 A2 cos of phi ka under root. Yes or no?
Yes, sir.
Or I can write the intensity of this wave as I1 plus I2 plus 2 times root over I1 I2 cos phi. Yes or no?
Yes, sir.
I can write the value of this xi, tan of xi, as A2 sine of phi upon A1 plus A2 cos of phi. Yes or no? No or yes?
Yes, sir.
Yes, sir.
Okay. Now remember, this amplitude A can be maximum or minimum depending on the value of this phi. Depending on the value of this phi, this amplitude can be maximum or minimum. Yes or no?
Yes, sir.
Now, for maximum amplitude or maximum intensity, this is all max. When the value of cos theta is maximum, what is the maximum value of cos theta? The maximum value of cos theta is +1. Yes or no? And when does this +1 happen? When theta is 0 or 360 or 720 or 540, no, not 540. 360, 720, then 360 multiplied by 3, then 360 multiplied by 4. Yes or no?
Yes, sir.
Even multiples of pi. For maximum amplitude or maximum frequency, your phi should be 2n pi. This is the general value. If you put n as 0, you will get 0. If you get n as 1, you will get 2 pi. If you put n as 3, you will get 6 pi. If you get n as 4, you will get 4 pi. Do we understand this? Yes or no? This was basically the phase difference between the two. If I talk about the part difference for 2 and pi phase difference, the part difference will become n lambda. Yes or no? That from that formula. Yes or no?
Yes, sir.
Yes, sir.
This type of interference where you get maximum amplitude, this type of interference where you get maximum amplitude is known as constructive interference. This type of interference where you get maximum amplitude is known as constructive interference. And what will be the value of A max? It will be equal to under root of A1 square plus A2 square plus 2 times A1 into A2. This is nothing but A1 plus A2 ka whole square. Yes or no? So you will get maximum amplitude as A1 plus A2. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this? If we talk about the maximum intensity, the maximum intensity will be root over I1 plus root over I2 ka whole square. Is everyone understanding this? Yes or no? No or yes?
Yes,
Yes,
sir.
sir.
Now, similarly, for minimum intensity, A min or I min, the value of cos phi should be -1. The value of cos phi will be -1. That tells us that the value of phi in general, in maths, it will be 2n plus 1 times pi. That will be the value of phi, or the part difference between them. This is all maths. We are doing maths. We are doing trigonometry. This will be 2n. You can write 2n minus 1 so that you can start n from 0. Okay, you can write 2n plus 1. You can start n from 0 into lambda by 2, odd multiples of lambda by 2. In that case, you will get minimum amplitude, and your minimum amplitude will be coming as under root of a1 square plus a2 square minus 2 times a1 a2, because cos phi is minus 1. So your minimum amplitude will come as a1 minus a2. Your intensity minimum will come as root over I1 minus root over I2 ka whole square. This type of interference where you have minimum intensity. One type of interference is known as constructive. So what will be the name of the other interference? What will be the name of other interference? One is constructive, so the other one would be destructive interference. Do we understand this? Yes or no? No, yes. Everyone
Yes, sir.
understand this? Okay, that brings us to an end of this class. I will keep this screen on so that you can note this. We will move ahead with the same thing in the next class. If you have any doubts, please come up to me. Else, this is a wrap from my end. Take care. God bless you. I'm still here. Anything you want to ask, please ask.